Alright, this lesson is a new method of factoring called factoring by grouping. So please pay attention and take notes. Alright, let's start with a little review problem. If I want to factor 4x cubed minus 8x squared minus 12x, you should know the very first thing to look for is a GCF. So what is the greatest common factor of all of these terms? Well, for the coefficients, I could take out a 4, and for all the variables, you're going to look and see that they all have the same variable, which they do, and then you're going to pick the one with the lowest power, so that would be x. So my GCF is 4x. When I factor out the GCF, what am I left with? Well, 4x cubed divided by 4x gives me x squared. Negative 8x squared divided by 4x gives me negative 2x. Finally, negative 12x divided by 4x is negative 3. So there you've taken out your 4x, which is your GCF. But the next thing you want to look for is a method that will allow you to factor further, if it's possible. It's not always possible, but let's see. If I look at this polynomial, x squared minus 2x minus 3, can I factor that further and break it down into a product of two binomials? Remember how to do this. You're just thinking, what multiplies to negative 3? So what will multiply to negative 3? That will be a sum of negative 2. Okay, so let's think for a moment. Hopefully you've got it, and it's x minus 3 times x plus 1. Now don't forget about the 4x that you factored out in the beginning. That didn't go anywhere. It didn't disappear. That is still a part of the factored problem. So now you're all done. You're all set. Those are your factors. It is completely factored. 4x times x minus 3 times x plus 1. Okay, so with this new method, factoring by grouping, you're going to see situations that look something like this. Notice the x minus 4's are identical here. So when you have this type of scenario, we're going to be able to look at that group, that x minus 4, as a GCF almost. And so you're going to factor out the GCF to the outside, and then you're simply going to write down in parentheses what you're left with, which is 2x plus 5. I know that sounds a little crazy, but this is what it looks like when you're all done. If you factor that out, you would write this as x minus 4 times 2x plus 5. So that's what you'd be left with as your final answer. So let's do a few examples until you get the hang of it. First example, factor 2x cubed plus 3x squared plus 10x plus 15. Normally, the first thing you want to look for is a GCF, right? But if I look at this problem, there's not a GCF that works for every single term. So if there's not a GCF that works for every single term, we might want to try this new method called factoring by grouping. So the first step is to reorder the problem into different groups that have common factors. So that would be rewriting it something like this. Notice, if I rewrite it this way, the 2x cubed and the 10x have a GCF. Just those two terms. They do have a GCF. And then notice the 3x squared plus 15, those terms also have a GCF. So if we look at these terms separately, you should notice that we can take out a separate GCF for each group. So what do you think the GCF is of 2x cubed and 10x? First, think about the number that goes into 2 and 10. That would be 2. So the GCF here, 2, and then what else? X. 2x is the GCF for the first group. For the second group, the GCF that we can take out between 3x squared and 15, think about it. The only GCF we have here is 3. There's no x with the 15, so we can only take out the number 3. So now let's see what this would look like. If we factored just the GCF out of each group, you would end up with the following expression. 2x factored out of that first group looks like this. 3, factored out of the second group looks like this. So now we have it separated into 2 groups. Do you notice anything interesting when we do that? You should see that we're left with x squared plus 5 in this group and x squared plus 5 in this group. If they're exactly the same, then we can use this new method of factoring out that whole expression to get our final answer. So if I do that, if I factor out the x squared plus 5, and I write that like this, x squared plus 5, and I put it in parentheses, look at what's left. What is not highlighted? 2x plus 3. So what I'm going to do is write those remaining terms in parentheses as a product, and now you've just factored that big, crazy long polynomial as x squared plus 5 times 2x plus 3. That is what the answer is if you were asked to factor this big, long polynomial. All right, let's try one more example, maybe a little bit more challenging this time. Well, actually, we'll probably do 2 more. So let's do another one, and then we'll do a more challenging one. All right, so second example, factor x cubed minus 6 plus 2x minus 3x squared. First step is always to look for a GCF, but there's not a GCF that works for every single term in this polynomial. What we can do is use this handy-dandy new method of grouping. So let's think about how we could rework this problem so that I can, in fact, factor it by groups. So I can get it into 2 groups that each have their own GCF. If I were to reorder the polynomial as x cubed plus 2x minus 3x squared minus 6, notice the way I've grouped them. I do have a GCF that works for x cubed and 2x, and that GCF would be x. So let's go ahead and factor that first group. If I take out the x, I'm left with x squared plus 2. Now let's take a look at that second group that I underlined in purple. If you notice, there is a GCF between those 2 terms, and that GCF is simply negative 3. If I take out negative 3, I'm left with x squared, and then negative 6 divided by negative 3, that's positive 2. All right, take a look at what just happened. We've got x squared plus 2 over here, and x squared plus 2 over here. So we're going to go ahead and factor that out, and then write a product using parentheses of what's remaining. We have an x minus 3 left. So this would be how you write your factors. Done. Now let's see a more challenging example. Alright, this last example, we want to factor 63n cubed plus 54n squared minus 105n minus 90. So yes, there are some large numbers here, but do not be intimidated. Remember, the very first thing you always want to look for, no matter what type of factoring method you're using, is a GCF. So let's look at each of these terms and let's think for a moment. Is there a factor that can be taken out of each of these terms? There actually is. There's a number that can be divided into all of these. And that number is 3. So there is a GCF of 3 here. So before we do any factoring by grouping, let's go ahead and divide out that 3. So let's see what that would look like. If I take out the 3, 63 divided by 3. If you need a moment to use a calculator to figure these out, you may do that. But 63 divided by 3, that's 21. So we have 21n cubed plus, what's 54 divided by 3? That would be 18. So we have 18n squared minus, now 105 divided by 3, you might need a minute to do that, but you should get 35n. Finally, 90 divided by 3 is 30. So now that we've taken out that GCF, now we want to go ahead and regroup these so that we can take further a GCF from each group. So just take a moment and look at the terms. Try to think how you might reorder them so that you can just take out a GCF from each group. So take one moment and try to figure that out. Talk to somebody next to you and work on it. Okay, hopefully you took a moment and thought about it, but you should see that these are already grouped nicely for us. 21n cubed and 18n squared. Those already do have a GCF, so we could think of those as one group. And then negative 35n and negative 30, that also has a common GCF, so we could think of that as its own group. So there's actually no need to reorder anything here, which is really nice. So let's think now, what would those GCFs be? Well, for the first group, the blue group that I circled, 21 and 18. What number can you think of that can be divided out of 21 and 18? Well, that number happens to be 3. And now n cubed and n squared, the greatest common factor, remember you take the variable with the smallest power, so that would be n squared. So my GCF here is 3n squared. And I would be left with 7n plus 6. Okay, now take a look at the next group. What do negative 35n and negative 30 have in common? Well, that number would be negative 5. If I factor out a negative 5, think about what you're left with for this purple group. If you factor out the negative 5, negative 35n divided by negative 5, you get positive 7n. Negative 30 divided by negative 5, you get positive 6. Now one last thing I want to point out before you move on, this very first 3 that you factored out as a GCF, it's not going anywhere. It still is a part of your problem. Now I know this is big, I know this is messy, but you should notice something really cool that just happened. Yet again, we have a repeated expression. So we have this 7n plus 6 repeated. So that means we can use our handy-dandy factor by grouping method, where we can rewrite it as 7n plus 6 all by itself. Once you've taken care of that, go ahead and just write another set of parentheses and fill it in with the other terms that you haven't circled. That would be 3n squared, and that would be negative 5. Last but not least, don't forget about your little old 3. Don't leave it hanging. So your final answer to this crazy long problem is 3 times the quantity of 7n plus 6 times the quantity of 3n squared minus 5. Alright, I know this is a little bit tricky, but with some practice, you're going to get the hang of it just fine. Thanks for watching.